Just a quick follow-up of the Wolfenstein subdivision thing, or the pre-caching of this stuff. So we've got the floors, and the floor is mirrored up the top. These holes here are where the wall blocks would have been, but we're just looking at the walls, the floors for now. Two different modes, a cached mode and a dynamic mode. What the cache mode does is that the tiles on the ground, and I'll show you them in a second, can be pre-computed. If you hit enter now, you can see the density of the floor. So the further we get away from the camera, these things are dropping in the frequency of the points is dropping, so we've got much less dense vertices than what we have here. There's not really enough geometry for this to help. That's the long story and the short of it, really. It doesn't run worse, it runs pretty much the same, and a little bit faster sometimes, but our best bet to make a large Wolfenstein environment would really be culling, eliminating this overdraw in here. So we put the floors back in, hit the enter thing here. So when you're on this side of a wall, this black space here would be walls. What's normally happening is it's drawing all the floor behind that, all the ceiling, the walls, whatever other wall fragments are over there. It's a lot of extra work for it to do. Does it really need to do that? Probably not. I think one way is to, well, if you pre-computed the whole thing, that would be one way. You could run through and predetermine the visibility of walls around you from each position in the world, or each tile in the world, I should say. That's basically how visible worlds worked. You pretty much had a volume, and then you checked, can you see the environmental objects from this location, from the center of the volume, from the corners, from sampling points within there. So it was a brute force way of doing that. I wrote something in DB a long time ago, Dark Basic that is, to do this for the Kairos project, which we just sort of had to can eventually because it just got too slow. Even though that was hardware accelerated, the same thing was occurring. It was that if you just turn the camera towards the center of the level, for example, it was kind of a blocked out Wolfenstein kind of map that robots were meant to, you meant to program the robot to escape the map. But when we put the camera in first person, it just fell to pieces. It wasn't fast enough. So what I did is I made a very simple 2D visibility test where we sat inside the tile, sat inside one of these tiles here, and we just checked, let's run rays around here and see what we hit. In this case, that would actually work pretty well. So we could probably use the ray casting stuff that we've done beforehand in a pre-processed way, and then you might get some pop in here or there where something hasn't been hit. But what that would do though is it would eliminate, you're pretty much then only rendering things in the foreground, and stuff that's occluded by other stuff gets hidden away. The whole point of that would be to sort of keep the rendering costs pretty much consistent frame to frame. So regardless of where you were on the map, how much stuff is in front of the camera, it's not going to fall to pieces. Well, in theory anyway. Nice learning exercise for anyone who wants to take it up. Just here, for example, you probably could just do something as dumb as this, like where the camera is at the moment. If you scanned ahead and hit a wall, and then look, so okay, how big is this wall fragment here? and then set up a triangle, probably more like a rect really, wouldn't it be? From my point of view, through the wall fragment here, out into infinity pretty much. The rest of this goes here, and then as you scan around the world, you went, well, what's behind this? I did use an idea that was similar to this actually in another demo I wrote for Dark Basic years ago. What it did is that when objects were up close or near the camera like this that were tagged as being occluders, it would draw like a triangle onto the map, and then anything it was covering was removed from the map, so it wouldn't get processed to be rendered in front of the tile. So I imagine this was a wall here, building that was covering the whole screen. If there was a character on the other side of that, there's no point drawing them. But that's what would normally happen. Like with Z buffering, you eliminate the issue with sort of polygons popping in front of the other ones, but you don't actually eliminate the overdraw problem, because objects can be drawn in different orders, and you end up with all of this work getting put into objects that effectively have no impact on the frame at the end. Imagine there was a wall in front of us here, and then we're going to draw floors behind it. They're still being drawn, just the pixels aren't actually being rendered. So we're processing the polygon, running through strip by strip and going, all right, is this Z depth of this floor in front of something that's already in the Z buffer? If it is, we draw it. If it's not, we don't draw it. But we still got to process all the points in the pixel. So that's still costly, and quite costly on old cards in particular. But yeah, I mean, Doom is built around the whole idea of sectoring up the environment to make sure overdraw is as minimal as possible. And then even then, it's clipped to each other then. So you wouldn't want to have heaps of overhead trying to clip out overdrawing, because that could end up more costly than what the actual just drawing it in the first place can be. Anyway, have fun. Thanks for watching, and I'll see you next time.